Welcome dear students. In this session, we discuss about refraction of light. What do you mean by refraction of light? Refraction means bending. Refraction of light means bending of light. When will light bends? When it travels from one optical medium to another. So refraction means bending of light when it travels from one medium, travels from one optical medium to another, one optical medium to another. Okay. Then what is optical medium? The medium which allows light to pass through it is called optical medium. What is optical medium? The medium which allows light to pass through it is called optical medium. Examples air, glass, water, etc. The examples for optical medium. So then what is refraction of light? Bending of light when it travels from one optical medium to another optical medium. Don't confuse this refraction of light with reflection of light. In the previous session we discussed about reflection of light. What is reflection? Reflection is nothing but bouncing back of ray of light. But refraction means bending of light when it travels from one optical medium to another optical medium. For example, let us consider two medium. They are separated by a surface. Let us call this as medium 1 and this as medium 2. Any optical medium like water, glass, air, etc. Okay. Let us consider this as medium 1 and this as medium 2. These two medium are separated by a surface and this surface is known as interface. Here XY is the interface. Then what is interface? Interface is the surface which separates two optical medium. What is interface? It is the surface which separates two optical medium. So when a ray of light when a ray of light travels from one medium to another medium. For example, it travels from first medium to second medium. What happens? At the interface, it gets refracted. At the interface, it gets refracted. Let us draw a normal. So, this is called angle of incidence. That is the angle between the normal and angle between normal and when light travels from one medium to another medium, it bends towards the normal or away from the normal. But in the absence of the second medium, light travels only along a straight line because its velocity does not changes. So it travels only along a straight line. But in the presence of another medium, it gets bends towards the normal or away from the normal. Therefore, this ray is known as refracted ray. Here OA is the incident ray and OB is the refracted ray. So the angle between the incident ray and normal is known as angle of incidence, and the angle between this normal and refracted ray is known as angle of refraction. So this is the direction of incident ray in the absence of second medium. Okay. So what is refraction of light? So refraction of light is bending of ray of light. When will it bend? It bends when it travels from one medium to another medium. To better understand this, take a glass filled with water and dip a pencil in it. What you will observe pencil appears as bent. Why does the pencil appears as bent? Because of refraction of light. Here, light travels from this air medium. This is the air medium. This is water medium. Light travels from one medium to another medium. It gets bent. Actually, pencil is not bent. But when we see the pencil through water, light travels from air medium to water medium. So it appears as bent. This is the refraction of light. Okay. Next, laws of refraction. Very important laws. That is laws of refraction. Okay. So like the refraction also has two laws. That is first law and second law. So first law of refraction. This first law of refraction states that the incident ray, the refracted ray and normal at the interface at the point of incidence all are lying in the same plane. Once again I repeat, the incident ray, refracted ray and normal at the point of incidence to the interface all are lying in the same plane. Shall I write here? Incident ray, refracted ray and normal to the point of interface, all are lying in the same plane. Okay, this is the first law. In the figure you will observe that this incident ray OE, this refracted ray OB and normal. Don't confuse this normal as refracted ray. It is just an imaginary line. This incident ray OA, refracted ray OB and normal MN all are lying in the same plane like the plane of the board. So this is the first law of refraction. So next, second law of refraction. Second law of refraction. So the second law of refraction states that the ratio of sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. Sine of angle of incidence to the sine of angle of refraction is constant for a given pair of medium. Okay, the ratio of sine of angle of incidence to sine of angle of refraction is constant for a given pair of medium. For example, let us consider two medium. This is medium 1 and this is medium 2. Okay. When a ray of light travels from this one medium to another medium, here this is incident ray. It travels from first medium to another medium. Let us draw a normal line for this. This is the angle of incidence. Suppose this light travels from first medium to second medium. It's bend. It bends like this. So this is the angle of refraction. By measuring this angle of incidence and angle of refraction for this medium, for example, let us assume the medium 1 as air and the medium 2 as water. Any other medium, okay? We will observe here medium 1 as air and medium 2 as water. So, we will measure these values I and R. We will calculate the sine I by sine R. We will get some constant value, for example, like 1.33 in other value. We will get some constant value, that is 1. So assume that as 1.33. Suppose for the same medium, for these two same medium, if we increasing the angle of incidence, what happens? Angle of refraction also increases. If increasing the angle of incidence, angle of refraction or value also increases. But to calculate the value of sin I by sin R, you will get the same value of 1.33. That is same value. That is constant value. Calculate any sine ratio of sin I by sin R for the given same media, its value always remains constant. Not exactly 1.33, but it is some constant value. That is sin I by sin R is constant. This is the first law, second law of refraction. The second law of refraction is also known as Snell's law. Second law of refraction is also known as Snell's law. Once again I repeat. Snell's law is the ratio of sine of angle of incidence to the sine of angle of refraction for a given pair of media is constant. Refractive index. According to Snell's law, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. So this constant is known as refractive index. This constant is known as refractive index.
Start.
It's refractive index. According to the Snell's law, the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of medium, and this constant is known as refractive index. This constant is known as refractive index. This refractive index is denoted by the letter n, that is n. There you can read this as n21. n21, refractive index of second medium with respect to first medium. This constant can be written as n21, that is n21 is equal to sin I by sin R. Refractive index is the ratio, the refractive index with respect, sorry, refractive index of second medium with respect to first medium is the ratio of sine of angle of incidence to the sine of angle of refraction. You can also written this as n21 can be written as n2 by n1. Therefore, n2 by n1 is equal to sin I by sin R. Multiply this, we will get n1 sin I is equal to n2 sin R. This is another form of Snell's law, that is n1 sin I is equal to n2 sin R. Here n1 is the refractive index of first medium, n2 is the refractive index of second medium. Similarly, refractive index of first medium with respect to second medium can be written as n12. Refractive index of second medium with respect to first medium can be written as n21. Refractive index of first medium with respect to second medium can be written as n12 is equal to sin I by sin R. This n12 can be written as n1 by n2. That will be equal to sin I by sin R. Now you can relate this n21 and n12 as n21 is equal to 1 by n12. This is the relation between the refractive index of second medium with respect to first medium and refractive index of first medium with respect to second medium. Okay. Next, let you consider two mediums. Let you call this as medium 1 and this as medium 2. Already know that when light travels from one medium to another medium, it gets bent. That means it gets refracted. But for normal incidence, angle of incidence is equal to 0 degree. When light travels along the normal, it moves undeviated in the second medium. That is, angle of refraction is also 0 degree. Okay. For normal incidence, I is equal to 0, that is angle of incidence is equal to 0, and R is equal to 0, that is angle of refraction is also 0. So according to Snell's law, refractive index is n21 is equal to sin I by sin R. Here sin I is 0, that is sin R, that is also 0. So sin 0 is 0, again sin 0 is 0. So this 0 by the 0 is indeterminate form. This is indeterminate. Okay. Indeterminate. So this is the limitation of Snell's law. This is the limitation of Snell's law. That means Snell's law does not hold good for normal incidence. What is the limitation of Snell's law? Snell's law does not hold good for normal incidence. That means the refraction of light is bending of ray of light when it is incident obliquely. When it is incident obliquely, not normally. Okay. Optical medium. What is optical medium? I already told you that. Optical medium is the medium which allows light to pass through easily. The medium which allows light to pass easily is known as optical medium. For example, glass, water, air, vacuum, etc. This optical medium can be divided into two types. They are denser medium and rarer medium. Optical medium can be classified into two mediums, that is denser medium and rarer medium. Denser medium means The medium which has high refractive index. The medium which has high refractive index. Ri means refractive index with respect to another. The medium which has high refractive index with respect to another is called denser medium. Rarer medium means the medium which has low refractive index with respect to another medium. The medium which has low refractive index with respect to another medium is called rarer medium. For example, consider two mediums. Consider two medium like air and water. Here, the refractive index of air is less compared to water. So, in air and water medium, air has low refractive index, so it is the rarer medium, and water has high refractive index, so it is the denser medium. Suppose you compare water and glass medium. So for water and glass pair, water is the rarer medium, and glass is the denser medium. So denser medium is the medium which has high refractive index with respect to another, and rarer medium is the medium which has low refractive index with respect to another. Okay. For the denser medium, in denser medium, velocity of light is low. In rarer medium, velocity of light is high. So it is clear to know that the velocity of light is high in rarer medium and velocity of light is low in denser medium. Let us consider two cases. So first case, when light travels from rarer to denser medium. We know that when light travels from one medium to another medium, it gets bent. In particular, light travels from rarer to denser. That is, assume in medium 1, you assume the air. In medium 1, you assume rarer medium. In medium 2, you assume denser. Okay. Now, light travels from this rarer medium to denser medium. For example, this is the ray of light which travels from this rarer medium to denser medium. So, this is the incident ray. Let us draw a normal for this. This is the angle of incidence. What happens? It gets bent. Here the light travels from rarer to denser medium. The velocity of light goes on decreases. As a result of this, refracted ray bends towards the normal. Because velocity of light decreases when it travels from rarer to denser medium. This is the angle of refraction. But the actual path of light is this. Okay. But when it travels from this rarer to denser medium, it bends towards the normal. In this case, angle of incidence is greater than angle of refraction. When light travels from rarer to denser medium, it bends towards the normal. In this case, angle of incidence must be greater than angle of refraction. So, second case, when light travels from denser to rarer medium. What happens? Its velocity gets changed. That means, let's consider two medium, that is this as medium 1 and this as medium 2. This is the interface of two medium. Okay. So in medium 1 you will consider denser medium, in medium 2 you will consider rarer medium. When light travels from this denser medium to rarer medium, so this is the incident ray. Let us draw a normal line for this. Okay. Here light travels from denser to rarer. It bends away from the normal. It bends away from the normal like this. it bend away from the normal, because when light travels from denser to rarer, its velocity goes on increases. As a result of this, it's bend away from the normal. But in the previous case, it bends towards the normal because here velocity decreases. But in this case, velocity will increases. Therefore, it's bending away from the normal. So, this is the angle of refraction and this one is the angle of incidence. In this case, angle of incidence is less than angle of refraction. Once again, I will repeat that. When light travels from rarer to denser medium, it bends towards the normal. When light travels from denser to rarer medium, it bends away from the normal.
Yes.
So now the velocity of light and refractive index are related by the equation n2 by n1 is equal to v1 by v2. n2 by n1 is equal to v1 by v2. This is the refractive index of first medium, n2 is the refractive index of second medium, v1 is the velocity of first medium and v2 is the velocity of second medium. Now we know that refractive index is a constant. Refractive index is a constant. That means it doesn't have any unit and dimension. It is just a pure number. Refractive index is unitless and dimensionless quantity. It is just a number. Okay. So now relate this refractive index. Now we define refractive index in another way. That is n is equal to c by v. So here n is the refractive index. C is the velocity of light in vacuum and V is the velocity of the medium. That means refractive index is defined as ratio of velocity of light in the air or vacuum to the velocity of light in the medium. Refractive index is also defined as ratio of velocity of light in the air vacuum to the velocity of light in the given medium. Next, consequence of refraction. Mainly there are two consequences occurs in refraction. They are normal shift and lateral shift. Normal shift and lateral shift. Okay, first we shall discuss about lateral shift. Let us consider a rectangular glass slab. Let us consider a parallel sided rectangular glass slab like this. Let us assume this as medium 1, that is air, this as medium 2, that is glass, and this as again medium 3, that is air. This is the air medium, this is the glass medium, and this one is the air medium. When light travels from this air medium to glass medium, that is medium 1 to medium 2. Here air is rarer medium and glass is denser medium. When light travels from this rarer medium to denser medium, let you draw a normal line for this. This is the angle of incidence and this is the normal line, that is MN. So point of intersection is called as O and this incident ray as OE. Okay. When light travels from this rarer medium to denser medium, what happens? Its velocity gets changed. When it travels from rarer to denser medium, its velocity decreases. Therefore, it bends towards the normal like this. This refracted ray bends towards the normal. So this is the angle of refraction. Okay. When now this ray is incident at the another interface. Let us draw another normal for here. Okay. So when light travels from this to this, that means denser medium to again rarer medium, its velocity goes on, increases. Therefore, it bends away from the normal. This is the angle of this ray is known as deviation ray. So this is emergent ray. So this angle is called as angle of emergent. This one is the angle of refraction, that is R1, and this is the angle of I can write here. This is the angle of incidence for the second ray, I2. Okay. So when light travels from rarer to denser, its velocity decreases, it bends towards the normal. Again, light travels from denser to rarer medium, its velocity increases. As a result of this bends away from the normal. But in the absence of this glass medium, light travels only along the air, that is denser medium. So the actual path of light ray is this. So this is the actual path of light ray. But due to the refraction, its path gets changed. So this shift is known as, this shift or this perpendicular shift is known as, this shift is known as lateral shift. That means this is the incident ray direction and this is the emergent ray. So lateral shift is the perpendicular distance. Perpendicular distance between what? So perpendicular distance between the emergent ray and direction of incident ray. Then what is lateral shift? Lateral shift is the perpendicular distance between the emergent ray and direction of incident ray. Okay. Normal shift. I think it is easy to understand this to you.
Start.
I think next normal shift, I think it is easy to understand you because it is observed in your day-to-day life. For example, you take a beaker or a glass filled with water like this. Pour with water and put a coin at the bottom of the beaker. Put a coin at the bottom of what? Bottom of the beaker. When you will observe this coin, from here, what will you observe? You will observe the coin appears as shifted. The coin appears as shifted upwards. The coin appears as shifted upwards. This is known as normal shift. But in the presence of other medium, that is water medium, the coin appears exactly in the same position. But in the presence of this second medium, that is water medium, it appears as shifted upwards. So this is known as normal shift. But actually the coin position is exactly at the same original position. It appears like a shifted. So this original depth of the coin is known as real depth. Okay. This position, this shifted position is known as apparent depth. This is known as apparent depth. So the shifting position of the coin is known as normal depth. That is, the shifting position of the coin is known as normal depth. So mention this distance as apparent distance, and this is known as normal shift. This shifting position is known as normal shift is defined as the shift in position of an object. This is object. So shifting position of an object where it is viewed normally from one medium and the object is kept in another medium. So shifting position of an object kept in one medium and viewed normally along the another medium is known as normal shift. Let me draw the ray diagram for this normal shift. This is the interface of two medium, and this one is the first medium and this one is the second medium. Okay. When light travels, let us consider an object here. Okay, it is in denser medium. Assume this object is in denser medium. Let us consider a ray which is incident along normal direction. So for normal incidence, which travels undeviated, for this angle of incidence is 0 degree and angle of refraction is also 0 degree. Okay, let us consider another ray which travels from this denser to rarer medium. What happens? It gets refracted. Here the light travels from this denser to rarer medium. Its velocity increases. So it's bent away from the normal like this. It bends away from the normal. So this is the angle of incidence and this is the angle of refraction. Let us consider another ray which again travels from this denser medium to rarer medium. So this is the incident ray. Let us draw a normal for this. This is the angle of incidence. Again, this ray get refracted. It travels from denser to rarer medium. It's bent away from normal like this. This is the angle of refraction. When the observers see this object in this position, it appears as comes from this point. This object appears at this position. This is the shifting position. That means the refracted ray emerges backward, so meet at a point, and this point or this position the object appears. So this is known as normal shift. So normal shift is the change in position of an apparent, not change, that is apparent change in position of an object kept in one medium when it is viewed along normally through another medium. Okay, so this normal shift can also be written as Ns is equal to real depth into 1 minus 1 by n. So this is the relation between the normal shift and refractive index. That is Ns is equal to refractive index, real depth into 1 minus 1 by n, where n is the refractive index.